Alright, so solving a rational equation. First, how am I going to identify that I have a rational equation? Here we have an example, and if you notice, I have a variable in my denominator. When you're dividing by a variable, it's a safe bet that you have a rational equation. So our plan, when we're solving a rational equation, is to find the common denominator and then multiply every term, every piece that's going to be separated by a plus sign, a minus sign, or the equal sign. So here we have three terms. Once we find our common denominator, we'll multiply all three terms by the common denominator and then solve the equation that results from it. So let's first look at how do I find the common denominator. So in finding your common denominator, you need to factor all the denominators to see what they're made of. So my first denominator is x minus 2. It's linear. Both terms neither have anything in common, so we'd say this is prime, or it's fully factored. Likewise here with x plus 5, it's linear. The two terms in this denominator have nothing in common, so it's fully factored, or prime. And my third denominator, I have x squared plus 3x minus 10. Now you might recognize this as a quadratic, so let's see if it's factorable. I'm going to look at the last value, the c value. What would I multiply together? That gives me negative 10. That if I add those values together, I get 3, and it would be 5 and negative 2. 5 times negative 2 gives me negative 10. 5 plus negative 2 gives me positive 3. So this denominator would factor into x plus 5 and x minus 2. So the way we find the common denominator is look at what factors make up each of my denominators and look at how many times that factor occurs. So if you look in our denominators, the only two things we're actually working with are x minus 2 and x plus 5. So starting with x minus 2, if you look at each denominator, and look at how many times that factor occurs. So in this denominator, x minus 2 only occurs once. In this denominator, it doesn't occur any time, so 0 times. And in the third denominator, x minus 2 occurs once. So the most amount of times that it occurs is once. So I'll just have 1 x minus 2. And likewise with x plus 5. In the first denominator, I don't have any instance of x plus 5. The second, it appears once, and in the third, again, it appears once. So the most amount of times that x plus 5 occurs is once. So I'll just have a single x plus 5. That's all the factors in my denominator, so this is my common denominator. So I'm going to take each term inside the rational equation and multiply by my common denominator. So I'm going to have x minus 2 times x plus 5. And I'm going to multiply my whole equation by that. So 3 over x minus 2 plus 4 over x plus 5 equals 2 over x squared plus 3x minus 10. And so we're going to distribute, being careful to see what cancels out. So when we're multiplying fractions, if you have a common value in the top of the fraction and in the bottom of the fraction, then they cancel out. So when I multiply my common denominator by the first term, my x minus 2's cancel out, leaving me with just 3 times x plus 5, plus, moving on, multiplying my common denominator times the second term, the x plus 5's will cancel out, leaving me with just the 4 and the x minus 2. So I have 4 times x minus 2. Following the equation, I'll bring down my equal sign and multiply the third term times the common denominator. So recall, this denominator we actually factored. It's x plus 5 times x minus 2. Easier to see when it's factored. You'll see my x minus 2's cancel out and the x plus 5's cancel out. So the only thing I'm left with is the numerator, so the 2 comes down. Now the equation that results from that is linear. Right? The highest exponent of any of my x's is 1. I'm not dividing by an x, so it's not rational, it's just linear. So my goal here is to get all the x's on one side, all the plain numbers on the other. So I'm going to distribute the 3 into the x plus 5 and the 4 into the x minus 2 and combine like terms. So this gives me 3x plus 15 plus 4x minus 8 equals 2. Combining my like terms, I have 3x plus 4x gives me 7x, and 15 minus 8, the sign in front of a number goes with that number or that variable. So 15 minus 8 is positive 7. And now this is looking a little bit more like a standard linear equation. I'm still trying to get all the x's on one side, plain numbers on the other, so I'm going to subtract 7 from both sides. It's being added, so I'll subtract it, bring down my 7x. 7 minus 7 cancels, 2 minus 7 is negative 5, and divide by 7, so I end up with x equals negative 5 over 7. Now with rational equations, you do have to be careful because we are dividing by a value, and if you remember with division, the only value we can't divide by is 0. So what would give me a 0 in my denominator here? Well, if I plugged in 2, 2 minus 2 is 0, so I would have something undefined. So the rational equations do have restrictions. I know if I plug in 2, I'm going to have a problem. So restrictions, in this case, will be x is equal to 2. And take a second, what would I plug in to the denominator here? That would give me 0. It is negative 5, so another restriction I have is negative 5. So I know that x cannot be equal to 2 and x cannot be equal to negative 5. The third denominator is made up from the first two, so the restrictions are still the same. It can't be 2, it can't be negative 5. Now, what's the significance of that? When you solve, if your solution ends up being one of the restrictions, then that solution is what we call extraneous, so it's not really a solution at all. The solution that we got was negative 5 over 7, which is neither of my restrictions, so I know that my final solution is actually a solution. So x equals negative 5/7.